Good morning, guys. In the previous class, we have seen briefly the basics of the Hadoop IO. What is the writable, importance of writable, we have seen, and Java concept, what are the data types in Java, interface in Java, serialization in Java, we have seen. Next class, we have seen why writables are introduced in Hadoop. What will happen if writables are not available in Hadoop? We have seen these things in the previous classes. Clear. From the previous classes, what we have understood is writables are used in Hadoop for implementing serialization and deserialization. If writables are not present in the Hadoop, what will happen? Since Hadoop has no alternative, so Hadoop has to use the Java serialization and deserialization. If writables are not present in Hadoop. Since Java serialization is creating huge amount of data, huge, okay, the data size of the Java serialization is very high. Okay, that's what a big problem for Hadoop. That's why Hadoop is not directly preferring the Java serialization. It is using its own serialization with the help of this writable interface. That is what we have learned in the previous class. Now today we have to see briefly about that. What is this writable interface? How it look like? Next we have to see what are the write comparable. How it look like? Okay, today class we have to see about these two things. What is this writable interface? What is the syntax of this writable interface? Next, what is this write comparable interface? We have to know about briefly about these two interfaces. Theoretically, we will learn in the today class. See, to provide mechanism for serialization and deserialization of data, Hadoop provided two important interfaces. Hadoop has two important interfaces are there, which are used to achieve serialization and deserialization in the Hadoop. Okay, to achieve the serialization, deserialization of data, Hadoop has two important interfaces are there. Those two are nothing but the writable interface as well as the write comparable interface. We already heard the word writable interface. Now when we are getting one more new word, write comparable. It is a single word. Remember that one. There is no space at all. Write comparable interface. Okay, writable interface as well as the write comparable interface. We have to see about these two now. First, we will learn briefly about the writable interface. Then we will go for the write comparable interface. We will see what are the syntaxes of this one, writable interface as well as the write comparable interface. Now, when we come to this writable interface, okay, writable is an interface in Hadoop. Hadoop and types in Hadoop must implement this interface, and the data types in Hadoop must implement this interface. Writable is an interface in Hadoop, and the data types of Hadoop must implement this interface. We will learn about the data types of Hadoop later. In the next classes, we will learn. Clear. Writable is an interface in Hadoop which will, and it must be implemented by the data types in Hadoop. Clear. Generally, Hadoop has writable wrapper classes. Hadoop has writable wrapper classes for all Java primitive data types. Okay, we know what are the primitive data types in Java. Previously, we have seen byte, short, int, long, float, double, char, boolean. Okay, we have 8 primitive data types are available in Java. For these 80 data types in Java, 8 wrapper classes are there in Java. Similar to the wrapper classes of Java. Okay, Hadoop also contains writable wrapper classes. Writable wrapper classes for all these Java primitive data types. For the same Java primitive data types, okay, Hadoop provides its own wrapper classes instead of the Java wrapper classes. Hadoop has its own wrapper classes for all the primitive data types of Java. They are called as the writable wrapper classes. We call them as writable wrapper classes. Okay, Hadoop wrapper classes are called the writable wrapper classes. Java wrapper classes are normally called as the wrapper classes. Okay, generally Hadoop provides writable wrapper classes for almost all primitive Java primitive data types. But even though writable wrapper classes are present, but sometimes the user has to pass his own objects, custom objects. Okay, The user has to pass the custom objects. That means his own objects. Okay, he will create his own classes and he has to pass some custom objects. Okay, these are the predefined classes. Writable wrapper classes are the predefined, they are already available. But sometimes we have to create our own class and we have to pass that objects. Okay, for okay, on generally for these writable wrapper classes are useful for applying serialization and deserialization on the Hadoop data types. These writable wrapper classes are available. With the help of these writable wrapper classes, okay, Hadoop can implement serialization and deserialization on the data types of Hadoop, directly on the data types of the Hadoop. But sometimes the user has to use his own object, that is custom objects. For those custom objects, to apply the serialization and deserialization, those custom objects must implement the, okay, it must implement the writable interface. Okay, whenever the user is creating his own object program in the program, that object must implement the Hadoop writable interface. For example, I have created my own class A, and for class A I have created an object A1. Since A1 is a custom object, my own object, okay, to apply serialization and deserialization on this object A1, okay, that object must implement the writable interface. That means to which class it belongs. This object A1 belongs, it belongs to capital A, class A. Since the A1 is object A1 belongs to class A must implement the writable interface. Why? Because class A is not a predefined one, and A1 object A1 is not a predefined object. It doesn't have any wrapper class. Clear? For the predefined objects, for the predefined Hadoop data type, sorry, for the Hadoop data types, writable wrapper classes are available. So they have no problem. Already writable wrapper classes are available for them. But when we come to the custom objects, for the custom objects, okay, they must implement the writable interface. Then only it is possible for applying serialization and deserialization on those custom objects. Here, custom objects means nothing but the user-defined objects. See, when we come to the Hadoop MapReduce program, which is our third int we have seen. Okay, when we come to this Hadoop MapReduce, okay, the MapReduce uses implementations of Writable for interacting user provided mappers and reducers. Okay, to interact with the user provided mapper code and reducer code. Okay, the Hadoop MapReduce must use the implementations of Writable. We will understand later how mappers and reducers are using this Writable interface. We will learn in the future classes. Okay, Hadoop MapReduce program generally contains mappers and reducers will be their mapper code and reducer code. They must implement the writable interfaces. Okay, that is the point here we have to understand. This is the first thing is Hadoop writable interface is a interface, and all the data types in Hadoop must implement this interface. For the predefined data types of the Hadoop, writable wrapper classes are available. Next, for the custom objects, that means user defined objects. Whenever we have the user defined objects, they must implement the writable interface. Hadoop MapReduce program will use the implementation of writable interface for interacting with mappers and reducers. Okay, the writable interface, already we know what is an interface. An interface contains abstract methods will be there. Okay, an interface will contain only the abstract methods. Okay, similarly here our writable is also an interface. Okay, so it contains two methods are there. Okay, one method is one abstract method that is available in this one is write method. Write method is one abstract method that is available in the writable interface. Okay, this write method will take the object of data output stream. We will understand this one later. After seeing the syntax, we will understand what is this role of this data output binary stream. Okay, one abstract method available in the writable interface is the write method. Similarly, one more method is available that is called read fields method. These are the two abstract methods that are available in the writable interface, write method and read fields method. Simply to understand what is the use of this write fields method. Write method is used for data serialization. Read fields method is used for data deserialization. Write method is used for data serialization. Write method. We want to write the data into byte streams. We want to convert the data into byte streams. So write method is used for to convert the data into byte streams. Okay, that's why here data output binary string. Write method will give the data output binary string, whereas read method will take we use it for deserialization. That's why here it is using data input binary stream. It will take binary stream as input and will do the and it will perform deserialization. Okay, for performing deserialization we use the read field. For performing serialization we use the write method. Okay, to perform serialization we have to gather the data. Okay, the data will be written to the serialization method using write method. The write method will transfer the data from the file. The whatever the data you have given, the data will be transferred to the serialization method using write method. Similarly, read fields method is used for deserialization. It will read that data from the deserialization method and it will transfer the give the data to the original format. That is the thing. Write method and read method. Now we will see that this is a small syntax of this interface. How this writable interface looks like. The syntax of this writable interface is it will be like this: public interface writable, clear. Public interface writable. Already we know two methods are there: void write method, void read fields method. These two methods are available in this one. The write method will take object of data output stream. The read fields method will take data input stream object as a parameter. This is the parameter. Out is an object for the data output stream method. Okay. The write method will take input parameter, which is an object of the data output stream method class. Similarly, the data read fields will take an input parameter, which is an object to the data input stream class. Clear. And if exception rise, it will throw the IO exception. Why? Because here the things are all related to input and output only. The read and write method, read fields and write method are related to input and output. That's why if any exception was raised here, that exception is known as the IO exception. So they will throw the IO exception. So void road data output out throws exception. Void read fields data input in throws IO exception. Clear. When we come to this one, so which package this writable interface belongs to? The writable interface belongs to the following package: org.apache.hadoop.io. Okay, so which package it belongs to means the writable interface belongs to the package org.apache.hadoop.io package. Next, that means this read and write, these two methods also belongs to the same package. Next, here we are using the data output class as well as data input stream class, data output stream class. Okay, so we have to support the read and write method. We have to import the java.io.data input stream, data output stream classes. We have to use similarly since we are throwing IO exception. Okay, we have to import java.io.io exception. These three are the supporting packages for this interface. Okay, writable is belongs to this package org.apache.hadoop.in. For supporting that one, we are using this data output class, data input class, IO class. All these belongs to the java.io package, which belongs to Java classes. These are all the Java classes, and only this one writable interface is belongs to the Hadoop package org.apache.hadoop.io. Clear. Here, important point we have to remember is remaining three belongs to this data output, data input, IO exceptions belongs to the Java. Okay, these three belongs to the Java. Next, only this one writable interface only belongs to the Hadoop package. This belongs to the Hadoop package. Clear. That is the thing. The syntax will be look like this one. Briefly, this is about briefly about this one writable interface. Again, we will learn about this one in the programming part. We will see again this one. This is briefly this writable interface. Clear. This is briefly about this one. Next, we have to see one more interface is called the write comparable interface is there. Another interface is available here that is called the write comparable interface. Writable interface we have seen. What is this write comparable? The name itself giving some clue. What this write comparable will do for writable comparable? What is this writable comparable will do? Same task as writable. Additionally, it will do comparison also. It can do the comparison. Writable comparable can additionally do the comparison. Generally, the writable interface contains only two methods, read and write method. When we come to the writable comparable method interface, it can perform three things. Read, read fields will be there for reading for the applying deserialization. Write field will be there, write method will be there for serialization. Additional, along with those two, it will have one more method called compare to interface. One more abstract method compare to. Okay, it will have additionally compare to will be there. Here, this interface can be useful for users generally when we need comparison of the two objects. When we want to compare two objects, okay, then we use the right comparable. For normal direct serialization and deserialization, we use the writable interface. When sometimes we, while performing serialization or deserialization, or after performing serialization, we need to compare the things. For comparison of the things, we use the writable comparable. Okay. This writable comparable, see the point. This writable comparable interface is just a sub-interface of the writable and java.lang comparable interfaces. This writable interface is a sub-interface. It is a sub-interface for that for two interfaces, writable Hadoop writable interface and Java comparable interface. Java has one interface called comparable interface. Hadoop has one interface writable. Okay, this writable comparable is derived from these two interfaces. It is derived from these two interfaces. Okay, from writable and comparable of Java, we are getting the write comparable. Clear, that is the first point. It is not a separate own interface. It is a sub interface which is derived from writable interface of Hadoop and comparable interface of Java. From those two, we are getting this writable comparable. Okay, this writable comparable will have a method called compare to method. Along with the read fields and write fields, it will contain one more method called compare to method. Okay, for implementing a writable comparable, we must have compare to method apart from read fields and write fields. Along with read and write methods, compare to method will also be inherited into this write comparable. If you see the programming structure of this one, it will look like this one. Public interface, write comparable, extends, writable comma comparable. Okay, public interface, write comparable, it is getting properties from writable interface as well as it is getting properties from comparable interface. But this comparable interface belongs to the Java package, whereas this writable belongs to the Hadoop package. Clear. From the writable interface, it is getting two methods, read fields and write methods. Okay, for these two are coming from the writable one. These two are coming from. When we come to the third one, compared to it is coming from a Java comparable interface. From the Java comparable interface, it is getting the method compared to. From the writable interface, it is of Hadoop, it is getting read fields and the write method. Clear. The compare to, what is the use of this compare to? This compare to is generally used for comparison of two objects, whether two objects are same or not. To compare the object, generally we use this compare to method, which is belongs to Java comparable. Now this Hadoop writable comparable interface is getting the properties of Java comparable interface. See, the result of this compare to method is returns -1, 0, or 1. Okay, three values are possible for this comparative method, that is -1, 0, or 1, depending on whether the object 1 is less than the current object or not, or object 2 is equal to the current object or not, or greater than current object. For example, I have object A1. I am calling A1 dot compare to of A2. Current object is A1. Okay. And we are comparing the current object A1 with A2. A1 dot compare to of A2. It will return -1 if the A2 is less than the current object A1. It will return 0 if A1 is equal to A2. It will return 1 if A2 is greater than A1. Okay. So that is the syntax like this: A1 dot compare to of A2. When we want to compare the A1 current object A1 with A2, we will write like this one. The possible outputs are for this one is -1, 0, or 1. Okay. The above two interfaces, that is writable interface and write comparable interface. These two interfaces are belongs to which package? Apache.Hadoop.io package. Already we told. Okay. The above two which we have seen now, writable interface and write comparable interface, both will belong to the package Apache.Hadoop.io. Previously we have shown in the previous one also. Okay, they belongs to the package org.hadoop.io package. Next, continuation of this mapper, this one writable interface and write comparable interface. We have to know one more small concept called constraints on key values in MapReduce. Now we will go back to the MapReduce. When we go to the MapReduce program, already we told in MapReduce program, every page will take input in the form of key comma value pairs and give output in the form of key comma value pairs. We know that very well. In the MapReduce program, every phase will take input in the form of key comma value pairs and also output in the form of key comma value pairs. It will give the output. Okay. Mapping phase, shuffling phase, reducing phase. Mapping phase contains input splits and mappers. Reducing phase will contain the shuffling and sorting comma reducing. Okay, every phase will take input in the form of key comma value pairs and it will give output in the form of key comma value pairs only. Clear. When we come to this MapReduce program, key comma values in MapReduce. Okay, there are two constraints. That means constraints means conditions. There are two conditions that are available on the key comma values in MapReduce. Okay, Hadoop data types used in MapReduce for key comma value pair. Whatever the data types we are using for key and we are using for value fields of fields in the MapReduce program. Whatever data types we are using for key field and value field, they must satisfy two conditions, two constraints. First one is any data type used for value field. Any data type that is used for indicating value field, okay, must implement writable interface. Any data type we are using in the MapReduce program for value field must implement writable interface. Similarly, any data type we are used for key field in the MapReduce program must implement writable comparable. Remember these 2 points, which are important points and important questions. These are any data type used for value field in MapReduce program must implement writable interface. Value field must implement writable interface. Key field must implement write comparable interface. That means along with read write, it must implement the comparison also. Why? Because when we go to the MapReduce program, okay, the mapping phase or reducing phase both are done basing on the comparison of keys only. Okay, shuffling and sorting in the map reducing phase, we know shuffling and sorting will be done. That shuffling and sorting will be done only basing on the keys. By comparison of the keys only, it will do the shuffling and sorting. Clear. That's why the key field must be implemented with the right comparable way, because for the keys we must apply serialization, deserialization. So we are using read and write field. The write method and read field. Along with those two, key field has one more work is comparison is required for the key field. for shuffling and sorting part, we want to compare the key fields, whether they are same or not. Then, so that's why the key fields, the any data type we are using for key field in the MapReduce program must implement the writable comparable, and any data type used for the value field must implement the writable interface. Here, no comparison is required for the value. So simply writable is useful. Now I think you have some idea why we have two interfaces are there. Writable interface, write comparable interface. Two are available in the Hadoop. Okay, where we use the writable interface means in the MapReduce program. Okay, any data types which are used to represent value fields must implement writable interface, and any data type which are used to indicate the key field must implement writable comparable interface. Why? Because for the key fields to perform shuffling and sorting, we have to compare the keys. So compare to is also required. That's why they are implementing writable comparable. For value field, no need of any comparison. So no, simply writable interface is sufficient. Clear. This is briefly the today's class about today's class about this one. Okay, writable and write comparable. This is the today's class that is about this two. Writable and write comparable interface. Briefly, what are the writable interface? What is write comparable interface? What is the syntax of this one? What is the syntax of the second one? Next, where we are using this one? Okay, mainly where we are using the writable interface and write comparable interface. Tomorrow we have to see writable wrapper classes in Hadoop. What are the writable wrapper classes available in the Hadoop for Hadoop data types? For the Hadoop data types, what are the wrapper classes that are available that we will see in the tomorrow class? I think now today you have some rough idea on this one. What is this writable interface? What is its use? What is writable comparison? What is its use? Clear. We will see the writable wrapper classes in the Hadoop. We will see that concept on the tomorrow. We will see this one. Writable wrapper classes for Hadoop data types.